Okay, let's do one more looking at a velocity time graph. So describe the direction of travel. The velocity is positive the whole way, so that's to the right. Again, if it's positive, it's to the right. If it's negative, we're going left. We're in the right column. So there we go. Describe the kayaker's motion. So the velocity starts at 12. Looks like it ends at 4, so we're slowing down. We're decreasing velocity pretty smoothly. I think we could say it's a constant acceleration. What is the distance traveled? Well, actually, I'm going to do the second question first because it's easier. What is the final speed? Boom, 4 meters per second. Yeah, meters per second. That's what the thing says. So we got 4 meters per second. If I want the distance traveled, we got a couple ways we can do this. On a velocity time graph, the distance or the displacement is the area underneath. And you can calculate that looking at it geometrically. You have a rectangle here, you have a triangle up here. So a little bit of geometry, and that will work. I'm also going to look at it in terms of, well, I have a starting velocity, original velocity of 12 meters per second. I have a final velocity, Vf, of 4 meters per second, right? That happens over a certain amount of time, 18 seconds. So the time is 18 seconds. I want to know distance traveled. I want to know displacement. So that's my unknown. So as I'm setting this up, all of these things are my knowns. That displacement is my unknown. Now I'm going to set up my equation. So what pulls this together? I might have to use more than one. Right now I don't have something that takes me directly from velocities and time and distance all in one. So, but if I have the beginning and ending velocities, I could calculate the average velocity by just adding those up, dividing by 2, because it's a smooth acceleration, so the average is going to be right in the middle. And once I have an average velocity, I can do displacement equals velocity, average velocity, times time. And that will get me to. So basically now I have to think through, okay, as long as I can get to an average velocity, then I can use that to get to my displacement. So fourth step, substitution. Let's start here. I have 12 meters per second plus 4 meters per second over 2. So that is 8 meters per second on average. I'll plug that in over here. Distance equals, move my face, 8 meters per second times, I did that for, what did I say, 18 seconds. 18 seconds. And the displacement is something I can't do off the top of my head. 18 times 8 is 144. 144. And check the units. I was using meters per second times seconds. I'm left with meters. So that is the distance I've traveled, 144 meters. And again, every time we do problems like this, you're always showing your work. The setup, knowns and unknowns, the equation, what are you going to be using, how do you think you're going to do this, here's where the physics is involved, and after that, you crunch some numbers. You solve. I tended to set this up in a few columns this time because that's the space that was available to me. Some people like to go in columns. I leave it up to you as long as you can clearly see where you're going. And that final answer, have a variable. What is the thing that you calculated? What is the units it's measured in? So we can keep track of that. And yeah,